So as I said, we really appreciate D3R for taking our feedback, and also for CELPP. We have lots of interactions with Jeff, so he's very helpful. So first of all, we wish CELPP could take top 5 models for each prediction. I already talked to Jeff, and Jeff said that's okay. So maybe this also partly address past ask us like why the success like is only 26, like so we have 26% for the under 2 angstrom criteria, because that's top 1. If you allow top 5, the success rate should increase significantly. The second thing is that to discard targets with unreasonable, okay, I wouldn't call maybe not unreasonable, but say inappropriate ligands, such as very tiny ligands like heavy atom numbers smaller than 6, for example, ions. So right now, like for most docking, particularly for this large scale calculations, we don't consider ions detergents. Another thing is the cofactors. So right now we are asked to dock 1 molecule. So basically what we do is take the protein, then remove all the small molecules inside. But if they have cofactors, we are doing single ligand docking, and obviously we would get wrong results if there are actually 2 small ligands interacting with each other. That's good question. But right now, because this is large scale, we actually even don't look into what the targets are. We just say, okay. But that's actually, so another way, cofactors at least remind, maybe warn us there's a cofactor, maybe that's a way to address your question and also solve our problem. Oh, sorry, okay.
What about the metalloenzymes, how they are treated? So, for example, if you have some zinc enzymes which are crystallized with the cation instead of zinc, how do you manage that?
Yeah, so the structures that we send out for docking templates are straight from the protein data. And so if they have to be crystallized with the metal, it's there, but yeah, sometimes they'll crystallize the metallic protein and the metal will just be absent. And in those cases, it is ambiguous. This is something that we realize that there's a lot of input cases where weird stuff could happen, and we've also been looking at how we're handling cofactors. I think the correct thing to do in these cases is to filter these out at the end, put them in a separate scoring pool, and say, oh, this is really challenging, we didn't know what was going to be there. So we can still talk to them, but we don't want to, for general purpose talking, we don't want to say, oh, some of that got it wrong, or some of that.
Obviously, it will not work if you don't have the right meta or the right combination.
Yeah.
I'll just I'm just going to say that. So Jeff talked about last time, the filter part is filtering out nonsense, very non-drug-like ligands. If any are making it through, just let us know. But we have a blacklist of ligands that are forbidden, and there are some other criteria. So we just have to just stay tuned that.
Yeah. So that black mail list includes the detergents, those ugly ones. Yeah.
I'm
okay.
surprised you've seen these. We'll take a look at these.
No. I think in most cases fine, but just sometimes maybe Xinjing can also talk about that, like how often we see the detergents. Not many of them, yeah, but occasionally they would, yeah.
So we can tune that filter.
Yeah. Okay. So this thing also, I think also CELPP has improved a lot. Discard the targets with incorrect or unfavorable binding sites. So for CELPP, the very nice thing is that it would tell us where's the binding site. So most of the time they're pretty good. Like I think at the early stages, there's sometimes, I think it's not Jeff's problem, it's just the PDBs who can play to. Hopefully PDB people are not here. So maybe tell us, so give us the correct binding site. So another thing, this is something we also noticed that occasionally we have, sometimes there are trivial targets such as the ligands are identical and the proteins are almost identical. Maybe there's a little bit mutations. So if you could like check the similarity of the ligand and check the similarity of the protein sequence similarity for the protein. So then we could get rid of this.
So just to comment on the second one, and then the fourth, and then three. So 4, I think what may be more interesting and something we've contemplated is to come up with some sort of metric or potential metrics of how hard the docking case is. And that way we can stratify and say, well, even with a simple, very, very simple ligand, just didn't get it right, or we got all those right. I guess those different. In terms of the binding side, I mean, this is a chronic problem. We've spent a lot of time.
The reason the numbers on our slides in my slide is different is because, yeah, we catch the places where we incorrectly predict the binding site, and we don't score those, at least in the numbers section.
Basically, if the ligand ends up 10 angstroms away,
yeah, that's
really
yeah.
Then we end up not scoring it. So there are some where we pose it incorrectly, and we don't.
I see this product. Yeah, so in the future, maybe when we run into any problems, we'll just report to you immediately rather than report at the end of the work, like at a workshop, for example. So.
Yeah.
Okay, so that's all. Yeah.
Okay, I think we're probably ready to wrap up and go to lunch. Thanks, everybody.